graphing without a table. So I am going to quickly just recap the graphing form of a parabola. So we took a look at this number out front, this A, and that A tells you which direction the parabola is going, opening. So whether it's opening up or opening down. It also tells you if it has a vertical stretch. If you recall with the weight of the discs, that was a parabola that had been vertically smushed or vertically compressed, might have a number that is more than 1, in which case it would be a vertical stretch. The H, if you're subtracting a number, is going to tell you how much you're moving it to the right, or if you're subtracting a negative, you would actually be moving it to the left, and the K at the end is moving it up or down. So again, the A is opening up or down. The H that you're subtracting inside the parentheses is going to tell you left or right, translating it, and the K is moving it up or down. So I want to sketch and label a parabola that is negative 3.5, so it's upside down and vertically stretched. The vertex would be to the left 25 and up 5,000. So see if I can hide that. The vertex is to the left 25 and up 5,000. It's reflected over the x-axis. It's upside down and it's got a vertical stretch. So this is just a rough sketch. You can see my vertex here at negative 25 comma 5,000, and it is upside down. And I did not put any precise points on here. I don't know the exact x-intercepts, which we could get then with algebra. I just wanted a quick sketch to show you the direction that this is opening, etc. All right, our pod today, algebra review problem of the day. Given a function, p of x is x squared plus 3x minus 54, determine the vertex. I encourage you to pause the video and try this on your own, and then unpause the video and you can check your answer. So hopefully you did pause that video like I asked you to, and you found probably the x-intercepts. And so when you found the x-intercepts, I'm assuming you either used the quadratic formula or you factored it. You all know that factoring is my favorite, so I'm going to show you how to quickly factor it. I'm going to back up just a second to remind you when you're factoring, x squared goes in the lower left and the negative 54 goes in the upper right. The product of those two things is negative 54x squared. So we're looking for two numbers that have a product of negative 54x squared that add to a positive 3. So those numbers are 9 and negative 6, or 9x and negative 6x. And then when you figure out those numbers to put in the other corners of the rectangle, you can factor to the outside, and you know your factors are going to be x plus 9 and x minus 6, which tells you that the x-intercepts are when y is 0. So when y is 0, the x-intercepts would be at negative 9, or negative 9 comma 0, and positive 6 comma 0. So those are your x-intercepts. And then the vertex is halfway between those, or the x-coordinate of the vertex is halfway between those. So to find the axis of symmetry, I would find the average, add them together and divide by 2. I actually get negative 1.5 or negative 3/2. So that's the x-coordinate of the vertex. And then to find the y-coordinate of the vertex, I'm going to plug that x-coordinate back into my equation. I can either use the factored equation or the one that I was going to start. Because I am trying to do this without a calculator, I'm going to go ahead and plug it into the factored version. So negative 3/2 plus 9 and negative 3/2 minus 6. To add those fractions with different denominators is more of a challenge. So I'm going to convert the 9 to 18 over 2, and I'm going to convert the negative 6 to negative 12 over 2. That gives me positive 6 over 2 times negative 15 over 2. And the 6 and the 2 cancel, giving me a 3. So that's 3 times negative 15, or negative 45 over 2, which is negative 22.5. So the vertex is at negative 3 over 2, comma negative 45 over 2. All right, so there's our warm-up for today. Let's go ahead and get started on the new lesson. So the new lesson is to graph a quadratic, or to graph a quadratic function without making a table. So I want to get a precise graph, and that's probably easiest to do if it's in graphing form. So let's take a look at just a generic y equals x squared. I'm going to shut the door. My husband is mowing the lawn. All right, I'm back. Take a look at a regular x squared graph. We could probably get those points without making a table. You know it's to the right 1 and up 1, and it's to the right 2 and up 2 squared, which is 4, and it's to the right 3 and up 3 squared, which is 9. And then those 3 points that you've already graphed are reflected over the axis on the left-hand side, and we've got the same thing. So now if I just move the vertex, and so in this case, the vertex is going to be moved to the right 3 and up 1. I'm going to take that same parabola and just translate it over. So we'll start by putting the vertex on at positive 3, 1. And then I'm going to go ahead, and it looks like my picture is right in the way here. So hopefully you can follow along on your graph paper. You're going to go to the right 1 and up 1 squared. However, this one is stretched. So instead of going up 1 squared, you're going to go over 1 squared, which is 1, and then double it. So you're actually going to go to the right 1 and up 2. The next one, I don't think I can move that picture. I can get rid of it. Okay. You're going to go to the right 2 and up 2 squared, which is 4. But now you're going to double it because it is vertically stretched. So you're going to the right 2 and up 4 times 2, which is 8. So the next one is going to go 4 plus 2, which is 8. It's not letting me move my PowerPoint. Uh-oh. All right. And then finally, I'm going to go to the right 3 and up 9, except I'm going to double that. So it's actually going to be to the right 3 and up 18. I think that's going to be off my grid. So let's go ahead and put those points on, both to the right and the left of the vertex. And I should have put arrows on the ends of my parabola. That kind of bugs me. So please put arrows on the ends of your parabola as well. And I wish I could keep going and get that intercept. So we know that it was going to go to the right 1, 2, 3, and it normally would go up 9 because 3 squared is 9, but it's going to go up 18. And if it's 18 above where it started, the y-intercept is actually going to be at 19, so 0, 19, which is off of my grid, but I want you to see that we can actually get that number. All right, next example, take a minute and write it down, is 0.5 x minus 3 quantity squared plus 1. I think that was actually the same vertex, it's just that the vertical stretch, instead of being doubled, is actually cut in half. So our vertex is in the same spot, 3, 1. And this time we're going to go to the right 1 and up 1 squared, but then we're going to cut that in half. So we're going to go to the right 1 and up a half. Or I can go to the right 2. I normally would go up 2 squared, which is 4, but half of 4 is 2. So to the right 2 and up 2. And to the right 3 would normally go up 9, but this is going to go half of 9, which is 4 1/2. To the right 4, I would normally go up 16, but I'm going to go half of 16, which is 8. And it looks like I didn't do the 8, but we could do that one as well. Notice I put the points on both the right and left side, and then I would draw my curve, and I'm glad I put the arrows on this time. And so you can actually get as many points as you want, as long as you have enough graph paper to do so. And typically on a test or quiz, I will ask you to graph the vertex and then 6 other points, so 3 to the right and 3 to the left, maybe even 4 to the right and 4 to the left. So you should be able to do that without making a table and without a calculator. All right, the next ones I want you to do without a calculator, and then I want you to check your answer using your calculator. So you don't need me to check your answers. You can pause the video and work on them. Now the textbook, I think, gives you 6 of them to choose from because each person in your team was going to do 1 or 2. Because you're doing this on your own, I want you to do letter C and letter E. So you please work on those 2. Please do letter C on your own first, and then after you do letter C, then take out your graphing calculator, check your answers, and use the table to see if your points are in the right spot. So do it first without a calculator, use your calculator to check yourself. So pause the video and complete both of those. And I'm going to pause for a moment and assume that you've paused. I'm going to go ahead and restart here in a moment. So hopefully after you've completed letter C and E and G, you will be ready to go to the next slide. All right, in the next slide, we're going to take a look at number 33. So number 33 is again referring to this graphing form. And taking a look at this graphing form, we are going to kind of analyze what we know about it. So we know that the A tells you what direction the parabola is opening, if it's opening up or down, so that tells you the orientation. It also tells you the stretch factor, and then we finally can get the vertex out of this. And so if the quadratic is given in standard form, which is ax squared plus bx plus c, do you know any of those things? Do you know the vertex? Do you know the orientation? Do you know the stretch? And so we actually do know two of those things. We don't know the vertex from this form. We do know the orientation because it's the same A. And so we know if A is positive, it's opening up. If A is negative, it's opening down. We also know the stretch. We don't know the vertex. So taking a look at this equation, 2x squared plus 4x minus 30, without a calculator, could you tell me the orientation? And which of those things tells you the orientation? Which of them tells you the stretch factor? How do you figure out the x-intercepts and the vertex? And if the equation was in graphing form, we would want to sketch it including 7 points. So we know that it's opening up because the leading coefficient is positive. We know it's vertically stretched because the leading coefficient is a 2, it's more than 1. And to get the vertex, how would we do that? How could we get the vertex? Well, we did that actually in the RPOD. So to get the vertex, we found the two x-intercepts, and then we found the axis of symmetry, and then we found the halfway point between them, and then we plugged that x-coordinate in to get the y-coordinate. So pause the video, please. See if you can figure out your x-intercepts and your axis of symmetry and your vertex, your y-intercepts, and try to make a quick graph of this. So it can be a sketch. However, I do want you to have the specific x-intercepts, the specific y-intercept, and the specific vertex. And once you've got all that, see if you can write that equation in graphing form. So pause the video before you see the next slide. See if you can work on this one on your own. And when you're ready, go to play again and you can check your answer. Actually, I said that, but as I continued in my PowerPoint, I don't have the answer on the next slide. So hopefully you've checked your answer, or you can check your answer with your graphing calculator. All right, so in conclusion, we have a typical parabola that is centered with the locator point at the origin, 0, 0. It typically, without a stretch, goes to the right 1, or to the left and right, I should say, 1. It could go to the left or right 2 and up 2 squared, which is 4. It could go to left or right 3 and then up 3 squared, which is 9. And then from that parent function, we can change the vertex and also include a stretch. So this example has a vertex which has been shifted to the right 3 and up 1 with a stretch of 2. And we're able to go ahead and come up with additional points and graph that without using a calculator. And I think this exact same problem we did, and if you'll notice the red graph does not have a y-intercept, and I typically want you to have a y-intercept. So the y-intercept would be to the left 3. Typically it would go 3 squared, which is 9, but because this has a stretch factor, it's actually going to go up 18 units from the vertex. So it's going to go from 1 up 18. So it's going to be at 0, 19. You could actually get that y-intercept. All right, your review preview assignment for today's lesson is 35 to 41. So please do that using either your hard copy book or your online version, and then take a picture and submit. Thanks again. Have a good day. Look forward to seeing you tomorrow.